Hello dear friends, welcome to BYJU'S Exam Prep. I welcome all for this next session of GATE AIMER'S series of Discrete Mathematics. Of course, it is a crash course. We already completed two sessions, one on logic, the second one on logic and sets. And in today's session, we talk about the relations and functions, my dear friends. And this is about me, myself, Sridhar Sir. Hope you understand. So let us start with this topic, that is relations and functions, my dear friends. And you can all take this particular scholarship test offered by BYJU'S Exam Prep. My dear friends, this can give you around 90% reduction of the price. Okay, so please take a step towards success in GATE. Get up to 90% scholarship on preparation programs. Okay, so on 26th November at 8 p.m. you can register, my dear friends. So in description box there are so many Telegram groups. In that you can select any of them where you can find the registration process. You can log on to this BYJU'S Exam Prep app. There also you can find this registration process and you can get up to 90% scholarship on this GATE preparation programs, and not only GATE, other programs also, whatever you are interested in. Am I clear? So that is about it, sir. And this is about me. Okay, myself Sridhar Sir. I am having 20 plus years of teaching experience, and my qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad, my dear friends. And I am associated with BYJU'S from past 1.5 years. We are working on this particular project called Recorded GATE Content. My dear friends, it is first of its kind. Okay, no one can match this for sure. Even in the future, we created visualized animated content for you. Where you can find it? See, if you want to see the content under BYJU'S Exam Prep app, the category name, please note it, Learn with Video Lessons. You can find all the videos which were recorded by us. Okay, not only me, there are many people who recorded these content, beautiful content, my dear friends. Of course, now I am also coming before you in this live platform where we are connecting with you through YouTube sessions. Also, we are connecting with app sessions, paid sessions, of course many more sessions, my dear friends. Okay, so please do join our BYJU'S Exam Prep app if you want to get a very good GATE rank, because we are going to help you in the best possible manner, my dear friends. Okay, am I audible, visible for all of you? Any doubts in this? My audibility and visibility, all of you able to hear me carefully or clearly? Right? Very good. Now let me start the story. Straight away with problems. Today we solve only problems and more problems. And this was the homework problem which I given. Did anyone answer? I think yesterday, Pavi, you answered the question, but let us quickly see this particular question. How many binary strings of length 8 which start with 1 1 or end with 1 0 are there? They should start with 1 1 or end with 1 0, my dear friends. See, we all know the total number of binary strings of length 8. How many binary strings of length 8 are there? It's a Lilliput question, anyone can answer. This is number of binary strings of length 8. We all know this, so we take it as our universal set which contains 2 power 8. Yani, you all know what is it. So we are not very much interested in that answer right now. But here let us define two sets. One set I call it as binary strings of length 8 which start with 1 1. Which start with 1 1. How many binary strings of length 8 are starting with 1 1, my dear friends? That is 2 power 6, because first two positions are fixed. How many binary strings of length 8 start with 1 1, my dear friends? 2 power 6. And how many start with, oh sorry, next one is ending with some 0 1. So let us end with that. End with 0 1. So let us call it as set B. How many binary strings of length 8 which end with 0, 1, 0? See, end with 1, 0 means 2 power 6 because last two positions are fixed. Now you want either start with 1, 1 or end with 1, 0. So we want A union B. For that you need to find A intersection B. A intersection B means starting with 1, 1 and ending with 1, 0. I think 1, 0, right? So let me make it 1, 0. Otherwise people feel bad. Okay, 1, 0. So that would be what? Because first two bits are fixed, last two bits are fixed. So it is 2 power 4. Now what is that you want? Either start with 1, 1 or end with 1, 0. And that is given by 2 power 6 plus 2 power 6. That is number of elements in A plus number of elements in B minus number of elements in A intersection B. You can take 2 power 4 common. So 2 square means 4. 2 square means 4 minus 1. That is 2 power 4 means what, sir? 16. This is 7. 16 into 7. You can give the right answer, my dear friends. Straight away. Please try to give the right answer. If you are having any doubts, can also ask me. I am available live in front of you. You can all ask me the questions, my dear friends. Waiting for your response, Babu. Please respond. 16 into 7 is not a big deal for you. I think so. Otherwise, I use calculator to find the answer. What is the answer? Yes, not get. Not get the answer for this. Why, sir? Nayak Babu, why not getting answer? 16 sevens, how much you do not know? Okay, sorry, sound is troubling. 42, 7 plus 4, 11, 1, 1, 2. Naveen Nayak didn't get that. Oh, see dear friends, here we are having binary strings of length n, 8, which start with either 1, 1 or end with 1, 0. So I call the set of binary strings which start with 1, 1 as set A. So how many binary strings of length 8 which start with 1, 1 are there, sir? Because first two positions are fixed, na? Because the first two positions are fixed, na? So because first two positions are 1, 1, they can be filled in only one way. Whereas the remaining positions can be filled in two ways. Therefore, you get 2 power 6, my dear friends. Same is the case which end with 0, 1 means the binary string should end with 1, 0. So they can be filled in only one ways, whereas the remaining fellows can be filled in two ways. So it is 2 power 6. Now if you want start with 1, 1 and end with 1, 0, this is what you want. Start with 1, 1 and end with 1, 0. So these 4 positions can be filled in only one way. These 4 positions can be filled in only one way, whereas the remaining positions can be filled in two ways. How many 2's? 2 power 4. Hope you understand, my dear friends. Is the idea clear? Very good. Now, let us start with cross product, the next concept. See, can you answer this? If A is containing M elements and B is containing N elements, how many elements are there in A cross B? Number of elements in A cross B I want, my dear friends. How many elements are there in A cross B? How many elements are there in A cross B? Cartesian product. Suppose set A contains 4 elements, set B contains 2 elements. You can just answer this for number of elements in A cross B, my dear friends. How many? Very good, Naveen Nayak, super. M into N. M into N. So in this particular case, 4 into 2 it is 8. Now, here we are asking another question, number of elements in power set. Very good, Naveen Nayak, super, super, very good, sir. Very good. Okay, how many elements are there in power set of A cross B? See, my dear friend, whether it is A or A cross B, they are all sets. So yesterday we discussed power set. Number of elements in power set is 2 power n. So number of elements in power set of A cross B will be what? Number of elements in power set of A cross B is what? See, others also can answer, sir. Only Naveen, not just Naveen Nayak, who are watching. See, we start with a very simple problems. Then we, yes. 2 power, in this case, it is 2 power 8. Whereas in this case, it is 2 power mn, my dear friends. In this case, it is 2 power mn, my dear friends. So that is the general one. And why we need power set, my dear friend? Power set of A cross B. See, my dear friends, if you are having a set A and set B, A cross B will be set of all ordered pairs. That is, we are relating all the elements of A and B, my dear friends. But what is relation, my dear friends? A relation is a subset of A cross B. Any subset is a relation. So, you want to see how many subsets are there. So, that question is exactly same as asking how many relations are there from set A to set B. You are just asking the same question. How many relations are there from set A to set B? Am I clear? So, instead of asking number of elements in power set of A cross B, I can also ask you the question number of relations from set A to set B. How many relations are there from set A to set B? Because a subset means a relation only. Am I clear? Subset of A cross B means relation. So number of relations is exactly same as number of subsets of A cross B. That is exactly same as 2 power 8. Suppose this is the example. In this example, number of relations from A to B would be 2 power 8, my dear friends. It is 2 power 8, my dear friends. Right? Super. So always remember this idea, my dear friends. Number of subsets of A cross B he can ask you, or he can ask you number of elements in power set of A cross B he can ask you, or he can ask you number of relations from set A to set B. All these are one and the same. Number of relations from set A to set B. Whether he asks this question, whether he asks number of elements in power set of A cross B, or whether he asks number of relations from set A to B, they are all one and the same. And all these questions were asked in GATE, surprisingly. So what is the answer for this? 2 power mn. 2 power mn. Got it? Wonderful. Hope you understand. And we need to understand one more point before continuing further, my dear friends. Before continuing further, we need to understand this particular point. The point is, see here. If you are having set A and set B, then you can get Cartesian product. A relation from A to B is subset of A cross B. Suppose if you want from relation from set A to itself, then you are going to consider A cross A. You are going to consider what? A cross A. So it is a relation, it is a subset of A cross A. And a relation from set A to A is what is called as relation on A, my dear friends. It is what is called as relation on A, my dear friends. Am I clear? It is what is called as relation on A. So if A contains n elements, I can ask you the question like number of relations on A. Number of relations on A. Naveen Nayak, you given the answer, but the question is little different. The question is little different than what you are expecting. I am not asking number of elements in A cross A. Okay, A cross A is n square, but number of relations on A, a very popular question. They can ask you this like number of binary relations. Now some people worry about what is this binary, sir? Arey, when you have two sets, binary to banega na? Binary 2, because you are relating two elements. You are relating two elements of set A and set B. Am I clear? So that's why it is called binary relation also. Naveen Nayak, it should be 2 power n square beta. ये 2 power n square है, n नहीं है. 2 power n square है ये. 2 power n square, not n. Please note that. Now we have one very interesting relation which we need to understand, that is called composite relation. Composite relation, my dear friends. Of course, you can define composite relation from set A to composite relation of two relations. Okay. Suppose we have a relation. Let us see here. let us say that, suppose you are having a relation from A to B and another relation say from B to C. We can have composite relation which we denote it as RS, which is set of all ordered pairs AC such that there we can find a B in the set B such that AB is in relation R and BC is in relation S, my dear friends. Don't worry about it. It's very simple logic. See, if order pair AB is in relation R and order pair BC is in relation S, in the composite relation, A will be related to C. That is, order pair AC will join composite relation party, my dear friends. Nothing more than that. Hope you understand. Hope you understand. Now let us see this example. Here we are having a relation from, relation on A means relation from set A to A. Now I want R square. I want R square, my dear friends. What do you mean by R square, Babu? R square means composite relation of R with itself. Composite relation of R with itself. That is what we call it as composite relation, my dear friends. Now, if you see this is R, again you need to take one more R, that is 1, 1, 1, 2, 2, 3, 3, 3, 3, 4. And let me show you the composition, how to write it. It's very simple, sir. Generally people mess up with this. There is nothing in this. Very simple. See here. You consider one order pair in first relation. That is, 1 is going to 1. That is, 1 related to 1 means 1 is going to 1. Now you see where this one fellow is going here. 1 is going to 1. 1 is also going to 2. That is 1 related to 1, where the second one is related to 1 and 2. So directly first one can be related to the last one and last two. So here, if you are having this R and this R, this order pair, that is 1, 1 and 1, 2 will be present in R square. Direct composition. That is what it is called as composite relation, my dear friends. We call it as composite relation. Now let us take the next order pair. 1, 2. Means what? 1 is related to 2. Now see where this 2 fellow is going in the second relation. 2 fellow is going to only 3. So directly what you do? 1, 3 will join the party. That is 1, 3 will join the R square party. 1, 3 will join the R square party. All of you able to follow? Is the idea clear? Now let us see in the next relation, which is 2 related to 3. That is 2 is going to 3. Now check where 3 fellow is going. 3 fellow is going to 3 as well as 4. That means 2, 3 will join R square party and 2, 4 will join R square party. 2, 3 will join R square party and 2, 4 will join R square party. And finally, of course we have not finally, 2 more are there. That is 3 related to 3. See, 3 related to 3, and where 3 fellow is going? 3 fellow going to 3, 3 fellow going to 4. That is 3, 3, 3, 4. And finally, the last one, which is 3, 4. Now check where 3, 4 is going. That is 3 related to 4. Now check where this 4 fellow is going. Now where this 4 fellow, but there is no relation. 4 is not related. Done. So now once you have, you can write what is R square, my dear friends. R square is 1, 1, 1, 2, 1, 3. Right? Then 2, 3, 2, 4. Then 3, 3. See, actually with diagram also you can solve it, sir. You just need to see with 2 edges from one vertex to other vertex where you can go. Using 2 vertex from one vertex to other vertex where you can go. If you can see directly with the diagram also you can solve this problem, sir. Using diagram also you can solve this problem. See, what are the elements? 1, 2, 3, 4 now. 1, 2, 3, 4. 1 in the original relation, 1 is related to 1. 1 is related to 2, 2 related to 3, 3 related to 3 and 3 related to 4. Now that is your original relation. This is your original relation. Now I am going to create R square, you see. 1, 2, 3, 4. Okay? Right? So now let us see. Using 2 edges, where you can reach. See, I can reach, using 2 edges, I can reach from 1 to 1. 1 to 1, again 1 to 1. So 1 to 1 can be reached using two edges. Now look here, using two edges I can go from 1 to 1 and 1 to 2. Two edges, 1 to 1, 1 to 2. That is, using two edges I can reach from 1 to 2. So 1, 2 will be there. You see, all these fellows will be present here. Now using two edges, can you reach 1 to 3? Using two edges, can you reach 1 to 3, sir? See, I can reach from 1 to 2 and 2 to 3. That is one edge and two edge. Using two edges, I can reach from 1 to 3. Therefore, 1, 3 directly I write the edge. 1, 3 directly I write the edge. That is, you have to identify the two vertices from one vertex to other vertex. Using two edges we are going to reach. That is, there is a path of length 2 from this vertex to that vertex. Then you connect them. Then you connect them, my dear friends. That is what is r square, my dear friend. That is what is your r square. Okay, so that is done. Next, 1 to using two edges, where else you can go? 1 is done. Now from 2. From 2 you can go to 3. Again from 3 to 3 is there. So 2 to 3 you can go. That 2 to 3 is there. Next, 2 to 3 you can go, and 3 to 4 you can go. Therefore 2 to 4 you can go, my dear friends. 2 to 4 you can go. All of you able to follow? It's not commutativity. It is like, transitivity we can say transitivity. It's not called commutativity. It is called transitivity, Navin Nayak. Okay? It is called transitivity. Please note that. Yeah. Next, what happens? 2 to 4. You can go from 2 to 4. This is done. Next, from 3, you can go to 3 to 3, again 3 to 3. Because that edge is there, any number of times you can go. So definitely 3 to 3 you can go, my dear friends. Then 3 to 3 you can go, and 3 to 4 you can go. Therefore 3 to 4 you can go. So 3 to 4 edge will be there. So this will be there, this will be there. So with diagram also, without writing all this, we can with diagram also we can create r square, my dear friends. But for that, not commutativity, transitive idea you should have. Means from one vertex to other vertex, if you can reach with a path of length, not path, you can say actually walk of length, we should say. Path, not the path is correct word here, walk. Because same edge can be repeated any number of times, no? So with walk of length 2 if you can reach, that will be present in your r square. With walk of length 2 you can reach, then that will be present in r square, my dear friends. See, this procedure everyone can do it. This procedure is what we need to master. There are some questions which are asked in GATE. If you can understand this, such questions can be answered just like that. Even later on we talk about Warshall algorithm also can be solved just by using diagram, my dear friends. Am I clear? Please try to understand. Now, after this relations part, we just move on to functions. Then we again come back to this relations on here, sir, where we try to talk about, different types of relations on here. But in functions we all know it, because everywhere we use functions, sir. What is a function? It is a rule which assigns every element of set A to a unique element of set B. Every element of set A is assigned to a unique element of set B. That is what is called as a function. And in functions there are two important concepts we should know. One is called finding inverse. The other one is called composite functions. For invertible function, that is f inverse exists. When f inverse exists, my dear friends, f inverse exists if and only if the function is 1, 1. We'll see number of 1, 1 functions, number of onto functions little later. First let us see 1, 1 function and the function is onto function. See, the 1, 1 function is what is called as injective function, sir, or injection, and this is what you call it as surjection, my dear friends. And if it is both 1, 1 and onto, we call it as bijective function, my dear friends. We call it as bijective function, my dear friends. So when f inverse exists, Babu, when f inverse exists, it should be both 1, 1 onto. And here actually for finding f inverse, we should have the function which is both 1, 1 and onto, then only it is defined. But if you see in this particular problem, domain and codomain or domain and range are not mentioned. So we assume that the domain and codomain are defined in such a way that f inverse exists. So here the concentration is finding f inverse rather than verifying whether f inverse exists or not. See, this property or this method is very important. I want everyone to see this carefully, my dear friends. See, the idea here is like this. When you have a function, this x fellow is mapped to f of x, function of x we call it. So this is what we denote it as y. So when you write a function value, here actually y in terms of x, y in terms of x you are going to get. So this f of x can be written as y is equal to x plus 3 by x plus 4. See here what is happened? Y is expressed in terms of x, my dear friends. But when you want inverse, see the story. For y, you have to find x. This is the story here in this direction, but you want in the reverse direction. For y, you want the pre-image. So y is mapped to what? So it may be mapped to some x, and that is what we call it as f inverse y, my dear friends. So for this, you have to write y, actually for function you are writing y in terms of x. So here for inverse, you have to write x in terms of y. You have to write x in terms of y. If you can do it, your inverse is ready, sir. It's all about that. Those who can understand this Lilliput idea, the rest of the story is simple story for you, my dear friends. A very, very simple story for you, my dear friends. So let us write down y in terms of x. So y is, okay, y in terms of x is given, that is y is equal to x plus 3, sorry, it is running away from us. Y is equal to x plus 3 by x plus 4. Here y in terms of x, what is given? Y in terms of x. Try to write x in terms of y. Try to write x in terms of. See this particular part, you also get this type of questions even in your aptitude, sir. They ask this type of question even in your aptitude. It's not just for computer science students, only in discrete mathematics, sir. There are some topics in discrete mathematics which can be asked even in your aptitude, my dear friends. So please be ready. Okay? So please be ready. Now what happens? You have to write y in terms of x is there, so write x in terms of y. So what happens to this? Y into x plus 4 is equal to x plus 3, my dear friends. Got it? Clear or not? Yes or no? Now, what happened? All of you able to follow? Now you can write like this, sir. So I collect all x terms. So this x term, I take it this to the side. So xy minus x is equal to 3 minus 4y. So here I take x common, so that it becomes x into y minus 1 is equal to 3 minus 4y. That means x is equal to 3 minus 4y upon y minus 1. Very good. 3, Nayak Babu, you done a small mistake. Check that once. Because you are sending 4y to the other side, no? 3 minus 4y. Okay? It's not plus, it is minus. Please check that. Be careful. And this x is your f inverse y, my dear friend. Because x is what I told you. X is f inverse y. So whatever answer you got, that is your f inverse y, my dear friends. So you got f inverse y is equal to 3 minus 4y upon y minus 1. See, here we need to understand, yes. Here we need to understand this y which you used is a dummy variable. You can put y, you can put L, you can put P, you can put K, anything you can put dummy variable. So you can also write like f inverse x also. Just understand it as a dummy variable. Some people have trouble with this. So that x and this. That x also a dummy variable. Here this y or x, whatever you put, that is a dummy variable. You can write in terms of y. So you can write in terms of x also, my dear friends. And that is the story, my dear friends. All of you able to follow Babu? Any doubts? Clear to you all? Wonderful. Super. Nice. Move on to the next problem. Here in this problem, fx and gx both are given to you. And he says what is f inverse g of 5? Composite function. See, composite function you need to understand, sir. First of all, what is composite function? See, the idea goes like this, sir. Suppose you are having a function f and another function g. Suppose x is mapped to fx and this fx is mapped to g of fx. The composite function is direct mapping from this first set to the last set. We denote it as g circle f. Am I clear? It is a mapping from A to C. Now how it is defined, my dear friend? The composite function is defined as g circle f of x is equal to the same thing, g of f of x. See, if they give range and domain, you have to first verify whether it is 1, 1 and onto or not. You have to verify whether the function is 1, 1 and onto or not. Process will be the same. Okay? Once it is 1, 1 and onto, then you can say inverse exists, otherwise inverse does not exist. See, generally people feel the inverse problems are difficult, but actually they are very simple. You know why? Because it is invertible means it is 1, 1 and onto. It's very simple story, sir. The number of elements in first set and number of elements in second set are equal. Am I clear? And one element is mapped to one element. Such a simple story it is. It's like this. A very simple story actually. Okay? Right? So this is the story, my dear friends. All of you able to follow. Now, here we need to find F inverse circle G. Here we need to find F inverse circle G, sir. See, F inverse circle G means first function is G. The second function is F inverse. So this is what you need to do. Okay? But for that we need F inverse, sir. Fx is given. Fx is given as x plus 2. Can you find what is F inverse x? Just we solved now. Just like previous example. Can you find F inverse x, my dear friends? Just like previous example, find F inverse x. Then we can complete the story. Today we solve only problems, sir, all interesting problem. So we'll get outline together with the problems. Functions, then we do relations on set A also. Now look here. Here y is equal to x plus 2 means what, sir? X is equal to y minus 2. And that is your F inverse y. Yani F inverse y is y minus 2 means F inverse x is equal to x minus 2. And g of x is given as 4x plus 3. So you are having g of, okay, sorry, here itself we need to solve, sir. So what is that you need to find, sir? F inverse circle g of x. I am finding in general sense. Then whatever x value is there, you substitute and get the answer. So it is F inverse of g of x. What is g of x, my dear friends? G of x is 4x plus 3. So this is the argument. See, what is the work of this F inverse, sir? Whatever argument you give, you just subtract my 2 from that. So F inverse of this fellow is the argument minus 2, which is 4x plus 1, my dear friends. Which is 4x plus 1, my dear friends. So once you have this, you can write what is F inverse circle G of 5. That is 4 into 5 plus 1. Anyone answering it? Anyone answering? The answer is 21, my dear friends. Answer is 21, my dear friends. Okay. Super duper. Now let us see number of functions. Those who do not know the formula for number of functions, let me give you the formula for number of functions so that we can answer the questions easily. Okay. Suppose you are having a functions defined from set x to set y, then number of such functions from set x to set y is given by number of elements in y power number of elements in x. What is the formula? Number of elements in y power number of elements in x. So just use the formula number of elements in y power number of elements in x. That is 6 cube, my dear friends. So what is the answer? 6 cube, my dear friends. I think you can easily solve it. Very simple story. 2, 1, 6. Anyone answering? Babu. See, it's not theory. Theory with the problems I am doing it. So answers, if you can give, it would be interesting for us to continue further. Am I clear? See, completing is a simple story, sir, but when you interact, things would be much beautiful. These are all direct expected questions in GATE, my dear friends. They can combine this with probability. That also I am going to show you in a while. See that. Okay. So please note this point. For those who do not know, if you are having set X, set Y mappings, the number of functions is given by formula y power x. Number of 1 functions is given by formula yp permutation x. And onto functions, I'll solve a problem there. I'll explain how to find onto functions, my dear friends. Now please answer this question. How many 1 functions are there from set x to set y? How many 1 functions are there? Expected questions in GATE. Number of 1 functions. What is the answer? Number of 1 functions, dear. Number of 1 functions is what? So you want 1 function means number of 1 functions is given by the formula number of elements in set y p number of elements in set x, and that is given by y means 6 p 3, that is 6 factorial by 6 minus 3 factorial, that is 3 factorial cancel, so you get 6 into 5 into 4. So the answer for this is 120. The answer for this problem is 120, dear friends. Super. Any doubts? Now look here, we are having set x containing 3 elements, set y containing 5 elements. A function is selected at random from all possible functions from set x to set y. The probability that the function is not 1 function. So the selected function is not 1 What is the probability for that? What is the probability that the selected function is not 1 What is the probability that the selected function is not 1 See, my dear friends, you know number of functions, this would be total. For probability, this would be total. Total would be what? Number of elements in y power, number of elements in x, which is 125. Then you can find number of 1 functions. Then you can find number of 1 functions. That is not the variable. Variable is non 1 functions. So how many 1 functions will be there? 5p3, that is 5 factorial by 5 minus 3. 5 minus 3 means 2 factorial. So what is it? 5 into 4 into 3. 5 4s 20, 23 60, my dear friends. So this many 1 functions are there. Now how many functions which are non 1 function? Number of functions which are not 1 functions. How many not 1 functions? See, from total you remove 1 functions. That would be number of functions which are not 1. Or without doing it also you can do it, sir. Because probability will give you that particular story. What is the suppose you call it as some event A. We need probability that it is not 1 which is nothing but 1 minus probability that it is 1 my dear friends. Like that also you can do it. 1 minus it is 1 means 60 by 125, which is nothing but 65 by 125. Got it? So now you can simplify 5 1s, 5 3s and 5 25s. So the answer is 13 by 25, my dear friends. What is the answer? The answer is 13 by 25, my dear friends. Samajh mein aaya hai? Clear to you all? Super. Now number of onto functions. So the number of onto functions, if you want, Suppose this is 5 and this is 3. We start it like this. 3C0. Alternatively, plus minus you are going to get 3C0, 3 power 5. That is number of elements in X. And this power 5 will remain same. Whereas the next one is minus 3C1, 3 minus 1 power 5 plus 3C2, 3 minus 2 power 5. The next one is 3C3, 3 minus 3 is 0, so we stop there, my dear friends. So that will be the answer. So what is the answer? 3 power 5 minus 3 into 2 power 5. 2 power 5 is 32 plus 3C2 is 3. That's it. So 3 power 5, I think 243 minus 96 plus 3. That is 246 minus 96. I think 150. So the correct answer for this is 150. This number of onto functions is a very, very important question for GATE point of view, my dear friends. Many number of times they ask the same question in your GATE examination. So be ready. Now, if you consider a relation on A, we can classify a relation on A into different types. There are different types of relations on A. We call it as types of relations on A. Types of relations on A. When it is called reflexive, when it is called irreflexive, when it is called symmetric, let us see quickly. I'll write in one word. Everything I'll write it in one word, sir. When you call this relation on A as reflexive, my dear friends, you call a relation on A is reflexive if for all A in set A should be related to A, then we call it as a reflexive relation, my dear friends. Then we call it as a relation, reflexive relation. I'll take one example for this immediately after this. What do you mean by irreflexive, my dear friends? What do you mean by irreflexive relation, my dear friends? See, irreflexive means for all A in set A should not be related to A. A should not be related to A. That is what is called as irreflexive. See, some people feel like irreflexive means not reflexive. That is blunder, mistake, wrong. Please be careful. Irreflexive does not mean not reflexive, sir. Wrong. Please be careful. Irreflexive means the reflexive elements, that is AA type of element, should not be present in the relation. AA type of elements, okay, we call them as delta pairs or reflexive pairs. They should not be present in the relation. Then we call it as irreflexive. Then comes symmetric. When you call a relation as symmetric relation, my dear friends, a relation is called symmetric if, see here, A related to B, then B should relate to A. Here it is not for all AB belonging to, it is not for all AB belonging to set A, my dear friends. Here just where AB are elements of set A. Here what we are mentioning, whenever order pair AB is present in the relation, BA must be present in the relation. AB is present in the relation, then BA must be present in the relation, my dear friends. Please note that point. Is the idea clear? All of you able to follow? समझ में आ रहा है? Clear to you all? Yeah, any doubts? Next comes asymmetric. Even for asymmetric, people have misunderstanding. They feel that asymmetric means sorry to asymmetric. No, it's not like not symmetric. No, no, no. What do you mean by asymmetric, sir? Suppose if A related to B, then B should not be related to A, where AB are elements of set A, my dear friends. Where AB are elements of set A. यानी A B से relate हुआ तो B A से relate नहीं होना चाहिए. A B से relate है तो B A से relate नहीं होना चाहिए. That is what you mean by asymmetric relation. Then comes the most dangerous, what people feel, but not so dangerous. Anti-symmetric relation. What do you mean by anti-symmetric relation, बाबू? Anti-symmetric का मतलब ये होता है, अगर A related to B है and B related to A है तो then A must be equal to B where A, B are elements of set A. यानी अगर A related to B and B related to A है तो A must be equal to B. See, ये indirect speech है ये. This is called indirect way of defining something. See what it is, sir. Antisymmetric is asymmetric. What we need to understand actually is antisymmetric is asymmetric, which allows reflexive pairs. Which allows reflexive pairs. Means if reflexive pairs are there, no problem. Actually, every asymmetric is antisymmetric, but not every antisymmetric is asymmetric. You should know that. And the last one is transitive relation. What do you mean by transitive relation, my dear friends? If A related to B and B related to C, then A should relate to C, where A, B, C are elements of set A. So whenever it's like transitive property, the name itself tells you A related to B, B related to C, then A should relate to C. That is what transitive property, my dear friends. Let us take one example. A relation is given like this: A related to B if and only if A plus B is given. A plus B is even. This is how the relation is defined. A related to B if and only if A plus B is even, where that set is a set of integers, sir. Okay, this is the relation on set of integer. R is defined on set of integers. R is defined on set of integers, my dear friends. See how to verify reflexivity, my dear friends. See, for reflexivity, what we need? What is needed for reflexive, my dear friends? What is needed for reflexive? Every element should be related to itself. See here, when you say that A related to A related to A, if and only if A plus A, what is A plus A? 2A is even. But you all know 2A is even, right? For every integer, 2A is even. Correct or not? Let me rewrite this. See, A related to A will happen. A related to A will happen if A plus A is even. And you know that A plus A is what? 2A, which is even. Because A plus A is even, that means A related to A. That means it is reflexive, my dear friends. It is reflexive. See, I told you earlier one point. Irreflexive does not means not reflexive. But one point you can easily understand. Whenever it is reflexive, it cannot be irreflexive. And whenever it is irreflexive, it cannot be reflexive, my dear friends. So suppose, if you get reflexive, you can say definitely it is not irreflexive. So if someone asks you irreflexive, you say, Babu, go home. It cannot be irreflexive. See, when it is reflexive, it cannot be irreflexive. If it is irreflexive, it cannot be reflexive. But if it is not reflexive, you cannot say it is irreflexive. That is wrong. Please note that point. Got it? And next one is symmetry property. Suppose A is related to B. Let A related to B. What do you mean by A related to B according to the definition of this particular function, Babu? What do you mean by definition of this particular function? Oh, sorry, I messed it. Sorry, we cannot revert. So let me quickly do this. I removed everything. Okay, let me quickly do it. See, the given relation is A related to B if and only if A plus B is even. So reflexive we already verified. Let me quickly write down what do you mean by reflexive, sir. Let us consider A plus A. A plus A is 2A, which is even. That means A related to A for all A. Therefore, it is reflexive. Reflexive is correct. Because it is reflexive, it cannot be irreflexive, my dear friends. If it is reflexive, it cannot be irreflexive. Then comes symmetry. See here, see this particular relation. A related to B if and only if A plus B is even. Now if you say A related to B, that means what? A plus B is even. But whenever A plus B is even, B plus A is also even. Correct or not? If A plus B is even, B plus A is also even. That means B related to A, my dear friends. So whenever A related to B, B must be related to A, my dear friends. B must be related to A. Therefore, it is symmetric. Now, once it is symmetric, can it be asymmetric, Babu? Can it be asymmetric, Babu? It cannot be asymmetric. If it is symmetric, it cannot be asymmetric. If it is symmetric, it cannot be asymmetric. Please remember. Now, what about anti-symmetric? See, whenever you want to say it is not, you can just give one example, my dear friends. See, what he says, A related to B, then B should not be related to A. But if A plus B is even, how can you say that B plus A is not even? That is not possible. Here, anti-symmetric means A related to B and B related to A, you have to take it. But you have to prove that they are not equal. Then it is not anti-symmetric. And whenever A related to B and B related to A, that can happen only when A equal to B, then it becomes anti-symmetric, my dear friends. So here I'll just give you a counter example. 2 related to 4. Why? Because 2 plus 4 is even. And 4 related to 2. Why? Because 4 plus 2 is even. But 2 is not equal to 4. Therefore, it is not anti-symmetric. It is not anti-symmetric, my dear friends. And the final one is transitive. The final one is transitive, my dear friends. The final one is transitive, my dear friends. What do you mean by transitive? What do you mean by transitive, sir? See, suppose if A related to B, that means A plus B is even. And B related to C means B plus C is even. These two are given. See, when A plus B will be even, sir, if both are odd, it will be even, or both are even, then it is even. Because B here odd means C must be odd, so that it becomes even. If B is even means here also B is even means this also even. That means if you consider B plus C, both can be odd or both can be even. So what does it mean? B plus C is also even. That means B related to, not B I should consider, A I should consider. A I should consider. A is odd and B is odd. Sorry, C, not B, sir, C. A is odd and B is odd. A is even, B is even. So in any case, A plus C is even, sir. A plus C is even. So what happens? A related to C, not B related to C you have to show. That is already there what to show, sir. We proved A related to C. Therefore, it is transitive. So this particular relation is reflexive, correct. Symmetric, correct. Transitive, correct. Anti-symmetric is wrong. So if it is multiple select question, they may ask formula session. Union of anti-symmetric, union of asymmetric, and union of transitive relations need not be the same. So if you take union of anti-symmetric need not be anti-symmetric, so this one is not true. So this is the correct answer, my dear friend. This is the correct answer. Intersection, anything is straightforward, sir. You can easily answer them directly. No issue with them at all. Am I clear? So if you just remember this, like union of, let me clear this and write. Union of anti-symmetric, asymmetric and transitive relations need not be the same. If you just remember this statement, you can answer this question very, very easily, my dear friends. Under the formula revision session, I discussed this formula in more detailed manner. You can just go through that, my dear friends. Number of reflexive relations. See, in formula revision session, I also given number of reflexive relations, number of irreflexive relations, number of symmetric relations, number of asymmetric relations, number of anti-symmetric relations. All these formulae were given directly, my dear friends. So here I am directly writing the formula. You should remember this direct formula, sir. If a set contain n elements, number of reflexive relations, how many reflexive relations are there, is given by 2 power n into n minus 1. So here n value is 4. This type of question was asked in GATE directly, sir. This was a GATE question only. So 2 power 4 into 4 minus 1. That is 2 power 4 into 3, which is 2 power 12. So the answer for this problem is 2 power 12, my dear friends. Answer for this problem is 2 power 12. Now number of symmetric relations. The number of symmetric relations is given by the formula 2 power n into n plus 1 by 2. How is it, sir? Very good question. See, my dear friends, if you are having a set containing n elements, number of elements in A cross A will be what, sir? N square elements. That is, we have n square elements. Suppose these are the n square elements. Now when you want reflexive, let me call this elements as 1 to n, sir. So these are reflexive pairs 1, 1, 2, 2 and so on. N are the reflexive elements. How many fellows are there? N are there. Remaining how many fellows are there? N, because total n square, n square minus n fellows will be remaining fellows. Now for reflexive, these fellows must be present. These fellows must be present. Whereas these other elements, that is remaining n square minus n elements, they may be present or absent, we don't care. So there are two choices for each of them. Two choices for each of them. So the answer for this would be 2 power n square minus n, that is 2 power n into n minus 1, my dear friends. So that is the answer for this. 2 power n into n minus 1, you get it like this. Same is the reasoning for number of irreflexive relations also. Number of irreflexive relations also 2 power n into n minus 1 only. Am I clear? Yeah. The next one is how many symmetric relations are there? See, this formula also can be derived using the same logic, Mr. Naveen Nayak, if you are watching. So 2 power n into n plus 1 is number of symmetric relation, because set A is containing 4 elements. Number of symmetric relations is given by 2 power 4 into 4 plus 1 divided by 2. That is 2 power 2 into 5. 2 power 10. So this is the formula for number of symmetric relations, my dear friends. Am I clear? Number of symmetric relations formula is this one. Is the idea clear? That is number of symmetric relations, my dear friends. See, this problem can also be made as probability question, sir. See, this type of problems they can also ask as probability question. That mixture is very, very possible, sir. Because for probability, what they can ask you, a relation is selected from a set containing 4 elements. What is the probability that it is a reflexive relation? So what is the probability of reflexive relation, they can ask you. See, probability of reflexive relation means denominator is total number of relations, numerator is number of reflexive relations. Numerator we already solved it, which is 2 power 12. What about denominator? Total number of relations. How many relations are there on set A? Because if A contains 4 elements, number of relations is given by 2 power 4 square. That is 2 power 12 by 2 power 16, my dear friends. That is 1 by 2 power 4 is the required answer for this. This type of problems they can just create like that. Okay? But instead of giving directly, sometimes to confuse you, they give you big statements also. Just read the question, you will understand, then you can answer the question. Ultimately, this is what happens. See, if you observe discrete mathematics questions, they will not be lengthy, sir. That any problem can be solved within 1 page. Logical, because logical questions will not be lengthy, sir. People do lengthy problems. University examination questions, they do it. You should understand the level of preparation for university examination and level of preparation for GATE examination. See, to make this subject very complicated, I can show you some problems where you will be doing for 2-3 pages also. Like, like number of relations or what type of relation, that type of problems, people keep on doing it. See, we should understand the logical level of the topic, what they can ask you. They just want to check whether you understand the logic or not. They will not verify your patience, sir. They will verify your logic. And most of the people, they verify your patience by lengthy problems. Of course, for university examination, 1 or 2 such questions will be there. If you are preparing for university examination, that's fine. But those who prepare for gate level, that is logically strong, university level questions, there are many students who come to me and say, sir, I completed your subject and I could able to get very good marks in university examination. They could able to do well. But if you do very well in your university examination, you cannot get very well in your gate examination. That is not possible. Okay. Hi Giriraj Sharma, I am fine sir. I am very very fine. Giriraj. Seeing most of the people after a long time because I have been away from, you know, students almost for 1.5 to 2 years. Okay, I was, doing this recorded gate content almost for 1.5 year. So I was away from students. So very recently, last 4-5 months, I come back. Again here also, every now and then I'm coming on YouTube, but not continuously. Right? Yeah. I'm looking totally different. I'm looking totally different. My attire and everything's changed or what? Huh? It is very much same, sir. I don't change much. Right. Now, what is possible number of antisymmetric relations? So, number of antisymmetric relations. Number of antisymmetric relations. That is given by the formula 2 power n into 3 power n into n minus 1 by 2. Substitute to get the answer. Substitute to get the answers. N is 4. Substitute to get the answer. 2 power 4, 3 power 4 into 4 minus 1 by 2. That is 2 power 4. Then 2 power 2 into 3, 3 power 6. By difference. See, those who understand logic behind this can solve any variant which they ask, sir. So properly understand the logic behind this. And you please join my telegram group, sir. This is my telegram group, CS_Sridhar, where you can get the PDFs of all the topics which I conducted here, my dear friends. What is transitive closure? See, you are writing gate examination, sir. Okay, this is one of the examination. Okay, you have to extend your, see, generally people feel, how can I remember? We cannot remember. You can remember, sir. It's not, if you keep on working on them regularly, you can remember. See, for example, from your home to your college, okay, first day, it may be difficult. But if you go regularly, you know shortcuts also, right? So you have to keep walking on that path regularly. Then you can think about the other ways of doing it, sir. First, start walking it. Before starting only, you put the restriction, how can I go to college? Then you can never reach your college, right? Whether it is college or cinema hall, sir, same story. Okay? Whether it is college or cinema hall or wherever, you want to meet your friend, dear friend, then you have to walk, you have to travel. How can you sit back, relax and enjoy? Okay, it happened for 1 year for most of the students, like, Corona. Corona helped students to think about this too much. Now it's we are beyond, or we are out of Corona. Recently I was hearing this, like, many people who are working also, they are saying that I don't want to come to office. But we can't do that for the examination. Okay, maybe you may skip going for classes and all, but you cannot skip understanding the concept and applying the concept, my friend. You have to remember. Okay, it will obviously happen, sir. Don't unnecessarily worry about it. How can I remember? Don't put that constraint on yourself. You will remember, sir. The people who ask such questions, they remember so many other things also. And they ask me, sir, why 2 problems only you done, do more problems? Like that also they ask. If you keep on working, you only think about more. Okay, you will ask for more. Transitive closure. Where is it now? Transitive closure. See, transitive closure means, of course, for this we use the Washer algorithm. It is the smallest transitive relation containing R. the smallest transitive relation containing R. So that is the transitive closure, my dear friends. And for this we have a beautiful result called Warshall's algorithm. So let me just introduce the Warshall algorithm here. See, the algorithm goes like this. Just write down the vertices. Within the diagram I am explaining 1, 2, 3, 4. This is 1, 2, 3, 4. See, originally 1 to 2, 2 to 3 and 3 to 4. See, what you need to do is you start from 1. You try to reach all the vertices which can take, or you try to reach all the vertices which are at a length 1, which are at length 2, which are at length 3, everything you try to achieve, my dear friends. So starting from 1, where all you can go, try to reach there, my dear friends. Starting from 1, where all you can go, try to reach there. So 1 to 2 you can go, and 2 to 3 you are going. 2 to 3 you are going, so you can go 1 to 3. Got it? Then 1 to 3 you are going, and 3 to 4 you are going, you can go to 1 to 4. Got it? Got it? So from 1 anywhere else you can go. 1 to 4 you can go. From 4 you cannot go anywhere else. 1 to 2, 2 from anywhere you can go. No. 1 ruled out. Leave it. Now from 2 you start. So one work is completed. Now start with 2. From 2 you can go to 3. Now from 3 where you can go, you see. From 3 you can go to 4. Therefore 2 to 4 you can go. Now you can go to 2 to 3. From 3 anywhere else? Nowhere else. Then 2 to 4 you can go. From 4 anywhere else you can go? Nowhere else. Done. Leave 2. 2 is done. Then go to 3. Using 3 to 4 you can go. From 4 anywhere else you can go? No. Done. So this is your transitive closure, my dear friends. We just denoted by R plus. So if you want, you can just write down this transitive closure, my dear friends, which is 1 2, 1 3, 1 4, 2 3, 2 4, 2 3, 2 4. Then it is 3 4. And that is the transitive closure, my friends. A very simple process. Okay. Of course, with matrix method also we can do it. But matrix method, if you do it, tomorrow morning you will get the answer. We don't have that much time, right? Then comes partially ordered relation. What is a partially ordered relation? We know that a partial ordered relation is a relation which is reflexive, antisymmetric, and transitive. A relation which is reflexive, antisymmetric, and transitive is called partially ordered relation. And a set together with partially ordered relation, is called poset, my dear friends. And you should know the famous posets, my dear friends. The famous posets, the famous fellows. We always remember famous fellows only. Set of integers with less than or equal to, set of positive integers with division, power set of a set with subset relation, set of positive divisors of n with respect to division. These are the popular examples of posets, my dear friends. Poset means partially ordered set. Poset means PO set, partially ordered set. Is the idea clear? That is what you call it as partially ordered set, my dear friends. And these are the famous posets. And whenever this is a poset, the same set with inverse relation is also poset. That is called dual. So for these fellows we have duals like Z with greater than or equal to, set of positive integers with multiple of relation, power set of a set with superset relation, and set of positive divisors of n with respect to multiple of relation. All these are also posets. Whenever these are posets, these are also posets. These are called duals, my dear friends. What are they called? They are called duals of each other. They are called duals. They are called duals of each other, my dear friends. Hope you understand. Wonderful. Now, partially ordered set can be represented with a diagram which is called Poset diagram ya to Hasse diagram. And how to draw Hasse diagram, my dear friends? So I'll just give you a simple technique here. See this. Here this fellow with division relation. So here what is the smallest element? 1. You draw 1 with a small circle. The next element is 2. Now tell me which elements are related to 2. Which elements are related to 2? That is, which fellows can divide, because relation is division. No? Which fellows can divide 2? 1 can divide 2. See, 1, no one is covering 1, then this 2 will cover 1, my dear friends. So what 2 will do? 2 will cover 1, my dear friends. 2 will cover. So we'll have a direct edge from 1 to 2. Then comes next. What is the next element? 3. Who are related to 3? That is, which numbers can divide 3? 1 can divide. See, 1 you not cancelled, so 1 can be covered by 3, my dear friend. 1 can be covered by 3, my dear friends. So we have a direct edge from 1 to 3. Then next number here in this list is 6. What numbers can divide 6, my dear friends? 1 divide 6, 2 divide 6, 3 divide 6. Now here 1 is already in the list of 2, so you cancel that. But 2 is not in the list of anyone. That is smaller element. Okay. And 3 is not the smallest element in any list. So leave it. So these 2 elements are covered by 6. So 6 will cover these 2 elements, my dear friends. 6 will cover these 2 elements. Am I clear? So the elements which are alone are covered by, we say that is covered by last element. So here 1 is covered by 2. Here 1 is covered by 3. The next one is 12. Who are related to 12, my dear friend? Who are related to 12? 1 is related to, that is, they are all the numbers which can divide 12. 2 related, 3 related, and 6 related. You already seen 1 is covered by 2, so cancel it. You already seen 2, 3 are covered by 6, cancel them. 6 is not covered by anyone, 12 covers 6. That is, you draw the circle of 12. You draw the circle of 12, and 12 covers 6, my dear friends. 12 covers 6, my dear friends. Then finally 36. Who are all related to 36, my dear friends? Every number divides 36. So 1, 2, 3, 6, 12, 36. 1 is already covered by 2, 3, cancel them. 2, 3 are already covered by 6, cancel them. 6 is covered by 12, cancel it. 12 is covered by 36. So draw the circle of 36. And it covers 12, my dear friends. It's a beautiful technique, my dear friends. We can spend an entire day on Hasse diagram only. But here it's a crash course. In a crash manner, I given the idea for that. So this is the Hasse diagram, my dear friends. How many lines are there in the Hasse diagram? Of course, you want, you can make it little beautiful also like this. You can draw this little beautifully like this also, my dear friends. Even this people draw. Am I clear? So if you observe little bit, you can draw little beautiful. If you write like this, there is nothing wrong. How many lines are there? How many lines are there? Number of lines. 1, 2, 3, 4, 5, 6. 6 lines are there in the Hasse diagram, my dear friends. There are 6 lines in the Hasse diagram. Okay. So this is about the posets, my dear friends. See, I'll be stopping here. Tomorrow we discuss graph theory, interesting problems, my dear friends, in this particular crash course. Okay. So we try to, in the GATE AIMER'S series, we try to discuss interesting problems on graph theory. All problems only, no theory. Anything required as someone asks this particular question, maybe I discuss, but I'll take up all interesting problems. Isomorphism, coloring problem, planarity, all these problems only I'll take up, and I'll come up with those problems, my dear friends. Because we need to understand all the outline idea for the crash course, my dear friends. Okay, so that I'll discuss tomorrow. And you can try this as homework problems. Which of the following is lattice? My dear friends. Okay, so this is a homework problem. We can complete this tomorrow. And now this is the time for promotions. Now, new series on GATE app for 2024 GATE aspirants. I am coming with C programming in this particular a new GATE fundamental series, my dear friends. And there is something called rank booster series also happening in app. So we also provide some very interesting series not on YouTube, on app. So you can attend all these to score maximum marks in your GATE, my dear friends. So please do subscribe to BYJU'S Exam Prep. You also get one more interesting thing in BYJU'S Exam Prep app. That is, you will find video lessons, recorded video lessons of mine. See, for computer science students, my recorded lectures, all these subjects, engineering mathematics, discrete mathematics, C programming, data structures and algorithms which were recorded by me are available on your app. They are done in a very comprehensive manner. See, almost every topic, like half an hour way we divided the topics. Number of topics are very, that is, we divided, like C programming, 42 sessions. Okay, and if you take discrete mathematics, 140 sessions, 136 to 140 sessions. Algorithms I done around again 140 sessions, like that. So this many sessions we divided every topic, so that we can discuss every topic in a very comprehensive manner. So you please go through this recorded GATE content created by us, my dear friends. Okay, and I require your feedback on that. Right? Thank you, my dear friend. That's all for today. We'll meet up tomorrow for graph theory, the most powerful, interesting, scoring topic in discrete mathematics. Not only in discrete mathematics, the knowledge of graph theory is also useful in algorithm scores. And of course, you can download this BYJU'S Exam Prep app. You can get the free e-books, my dear friends. They are already available in your Telegram groups, my dear friends. GATE workshops we are conducting regularly for the students who are very much interested in this GATE workshops. Please do join our BYJU'S Exam Prep app to join these workshops. Okay, where these workshops are designed in a very efficient manner to clear all your general doubts, my dear friends. And of course, there are some scholarship tests which are happening. 90%, up to 90% you can get in the scholarship test. Of course, some people ask me, sir, how to join and all. See, here I am just giving you the information. Any information the teachers will not sell, my dear friends. See, if you want to purchase any of these courses, many people, they correct me and they'll ask. But here, my dear friends, I'll just give you the information. We have counselors, separate verticals we are having, where the separate team will deal with that, my dear friends. I'll not sell any of the courses here. Okay. So for sales and other things, you need not contact me. You can directly get into your BYJU'S Exam Prep app, where the separate team will take care of that. They'll guide you for the process and all. But for subject related doubts, you don't go to them. They'll not guide you. For subject related doubts, you please come to me. I am here to help you, my dear friends. Not only me, the entire computer science team is here to help you. And we are going to come up with more and more, informative sessions and surprises. We are going to come up with a big surprise soon, my dear friends. Okay, so that's about today's session. Thank you.